In the second part of section 419, we're going to see how the construction of this compound generator helps with the stabilization of the output voltage that we see and are able to connect to the load. And what we'll do is we'll walk this compound generator through from no load to full load, and we'll see how its construction helps improve this output voltage stability. So here's our compound generator with the larger gauge wire in the series field and the shunt field connected in parallel to the armature. So what happens when the generator runs at no load? The current in the series coils would be zero. So, you know, if there's no load here, right, then there's no current flowing through the series coils. The shunt coils carry all the excitation current in that situation, and it produces the field flux just like the standard self-excited shunt generator that we looked at earlier. Now, what happens though is when we connect a load to this compound generator, the terminal voltage, you know, the current starts to flow, right? And because of that, the terminal voltage tends to drop because of that R sub O. But what happens is the load current now flows through these series coils. The flux that's developed in the series coils acts in the same direction as the flux in the shunt field. So what happens is as the current starts to flow, the additional flux compensates for the lost voltage that we would see without the series coil. If they're properly designed, the terminal voltage can basically remain constant all the way from no load to full load and compensate totally, almost totally, for that internal I times R voltage drop that we would see in the R sub 0. Now, one other little thing here in to wind this section up on compound generators, in some cases he talks about we have to compensate not only for the armature voltage drop, but also for a voltage drop between the feeder line, right, the supply between the generator and the load. Okay, so you know there's a supply that sits out here somewhere, and again, you know, we supplying a voltage to this generator. So what you can do to compensate for this drop, what could we call this? Supply drop. Okay, so supply drop, you can actually add 1 or 2 extra turns on the series winding so that the terminal voltage increases as the load rises. So it actually ends up going above the armature voltage when the load increases. And these are called over compound generators. Okay, so let's think about what we have up to this point. We have this over compound generator, we have a compound generator now, we have a separately excited, and we have a shunt parallel connection. And then there's one other that we'll look at that will sort of wind up the general categories of DC generators. We'll look at that one in a short video that will follow this one called 420.